So we started 8.2 and we started talking about confidence intervals, and we are specifically talking about confidence intervals for proportions when we're talking about anything in 8.2. We're talking about proportions. And we talked about that we have a point estimate plus or minus a margin of error. And then we finally figured out what the margin of error is made up of. It's made up of a z-star critical value and a standard error, which is basically the standard deviation formula, but we use p hat instead of p. That was what all that was, okay? And last time we looked at 8.2, we learned that the actual formula for this was p hat plus or minus the z-star critical value times the standard error, which is that. And so that's the formula for a confidence interval for a population proportion. P hat is the point estimate. Z star is the critical value. We can figure that out by using inverse norm in our calculator. And then we've got our standard error. So last time we talked about the Cristiano Ronaldo and his Instagram followers and what proportion were Americans. We took a sample of 500. 308 of them were Americans, and we used this formula to come up with an interval to estimate the true proportion that were Americans on his Instagram. Okay? And that is what I believe we finished up with the last time we talked about 8.2. Today, we're going to put all of this together, and we are going to do our first full statistical inference procedure. I know. It's exciting. Are you ready?
What is wrong?
To do a full statistical inference procedure, there are 4 steps. The 4-step process is state, plan, do, conclude. State, plan, do, conclude. Say it with me. State, plan, do, conclude. Again, state, plan, do, conclude. Mark, what are the 4 steps, 4-step process?
Conclude.
State, plan, do, conclude. Colin, what are the 4 steps for the state, plan, do, conclude. Maddie, how about it?
State, plan, do, conclude.
State, plan, do, conclude. Everybody got it? What are the 4 steps, 4-step process?
State, plan, do, conclude.
Very good. All right. It's kind of like your favorite thing ever, writing an essay.
All right, bro.
State is the introduction, if you will. It's that first little hey, this is what's coming up. Plan is when you kind of start building your argument or whatever it is that you're wanting to talk about. You're kind of putting in your evidence that you need for your final punch. Then the do, that's when you really hammer home your essay. That's that paragraph that you're yeah, I wrote that. Oh yeah, I did. And then conclude is obviously your conclusion statement. This is what I said, basically. That is what we're doing here. So here is our 4-step process. State. On state, what we're doing is we're introducing what we're doing. And this sentence right here will tell you exactly what you have to say. You don't have to write your own introduction paragraph. I am giving you a format. You just have to fill in the blanks. Okay? So we will estimate. We're estimating because we're giving an interval of an estimate. We will estimate the true proportion P of whatever it is you're talking about, U.S. adults, teens, whatever, at a C% confidence level. There's your sentence for state. Next, you go to plan. This is where you, again, build your argument. You show your conditions. We have those 3 conditions. Yes? Yes. We have those 3 conditions. We have to check the random condition to ensure that P hat is an unbiased estimator of P. We have to check the independent condition, the 10% condition, to make sure we don't have any pockets of bias happening. Then normal. We got to make sure we have a normal distribution of P hat so that we can use that Z star critical value, those Z scores. So we do those 3 conditions. Then we actually hit it hard and find the interval. That's the do part, all right? Do is when we actually construct the interval and get the values for the low estimate and the high estimate. And then conclude. You guys should be very familiar with this conclusion statement. We are C% confident that the interval from blank to blank captures the true blah, 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 blah. We've been seeing that for a while, okay? Now, I have been waiting a whole week to tell you this information. Do you remember maybe last Monday when we constructed that confidence interval for the Cristiano Ronaldo problem, and we had to get the p-hat and we had to add and subtract and we had to do all that? The calculator will do it for you.
Well, that's a waste of time.
The calculator will do it for you. And here's how. If you go to Stat and Tests, if you go to Stat and Test, so you'll have to hit the Stat button, and then you'll hit the right arrow to go to highlight where it says Test. You will see a very long list of all of the inference procedures that statisticians use. We are learning our first one. We will learn 13 of them. We are going to learn our very first one, and we are going to learn 13 total. So, they are not in order, however, on your calculator. The first one that we are going to learn is A, which is the 1 prop Z interval. That stands for one sample. So we're going to take one sample out of the population. We're going to construct a proportion interval. We're estimating a population proportion. We're going to use a Z star critical value, and we're making an interval of possible values. So if you will, please go ahead and go to Stat Test A and hit enter on A. You can also jump to it by hitting Alpha A if you want to. Stat Test A. You will see it's asking you for 3 things: X, N, and sea level. Does everybody see X, N, and sea level? If you are not seeing X, N, and sea level, you are not in the correct place. All right. The X, this is your number of successes. N, you guys know what N stands for, right? That's your sample size. Sea level. This is going to be your confidence level, but you got to put it as a decimal. So if we want to be 95% confident, you're going to put in 0.95 there. All right, so again, I know I keep referencing it, but we're going to plug it in so you can see it in action. The Cristiano Ronaldo problem from last week. So there were 308 Americans out of the 500 in the sample, and we did a 93% confidence interval. So if you want to go ahead and plug that in to your Stat Test A, 308 was our number of successes. That was the number of Americans in the sample. 500 was the total sample size, and 0.93 is the confidence level. Now I want to talk about what you're seeing on your output. Your calculator is going to give you the low estimate, comma, the high estimate. So literally in that moment when you hit enter, it did all of that math for you. It calculated all that for you. Then it gives you p-hat. Now you guys could get p-hat very easily. It's literally just the number of successes out of the sample size. It's whatever X over N is. You guys could get p-hat yourself. And then your calculator does go ahead and give you back the sample size. So that's what your output is. Basically, all you have to do is write down your output, and then you do label what you put into your calculator. And that's your do statement. That's basically what you would do under the do part for the inference procedure. So that's how you do it. Questions, comments, concerns?
The answer's Is this the right answer?
Yeah, so if you flip back one page, look at the back side of your notes there. We actually constructed this interval last Monday, and the interval that's on your calculator should match what we constructed by hand.
So we don't need to do by hand on the
You do not have to do it by hand.
What did you do?
Nope.
So, and then for like writing it down, we just have to put x equals n.
Yep.
Wait, so is our answer our low and high estimate?
Yep, your low and your high estimate would be what you would be looking
My
for.
answer says 1.95999.
Let's see. So you went too far. So stat test A. That is one thing to be careful about, guys. Don't hit enter too quickly on calculate. You just have to hit it one time and it pops up. If you hit enter again, it clears it away. And so just be careful. All right. You guys ready to do your first full inference procedure?
I believe so.
Let's do it. Distracted walking. A recent poll of 738 randomly selected cell phone users found that 170 of the respondents admitted to walking into something or someone while talking on their cell phone. We are going to construct and interpret a 95% confidence interval for the proportion of all cell phone users who would admit to walking into something or someone while talking on their phone. State. We will estimate. This is our introduction paragraph, basically. We will estimate the true proportion P of cell phone users who admit to distracted walking at a 95% confidence level. We have communicated that we're doing a proportion problem. We have communicated that we're estimating. That means we're going to make an interval. And we have communicated the percent confidence that we're going to have. Every time we need to construct and interpret an interval, that is your introduction statement.
Do we have to memorize all the stems?
Here's the good news. Yes, you need to memorize these sentences. The good news is this is what we're doing from now until mid-April. And you will know these sentences by then. That's the good news. Because you're going to use the same stems almost every time. All right, state is done. Plan. So, we're going to check our three conditions. Random. Random is our first one. This is to ensure that P hat is an unbiased estimator of P. We have a simple random sample of 738 cell phone users. So that one's good to go. Independent. We need to make sure that we have good variability and that we don't have any pockets of bias because our sample was too big. 10 times the sample size has to be less than the population size. 10 times 738. That is 7,380. Do you think that that is less than the population of cell phone users?
I just don't know.
I doubt it.
You doubt it?
Oh, wait, I bet it is, right?
Yeah. I bet the population of cell phone users is bigger than 7,380.
I'd say so.
So we got our random, our independent. Now we need to check normal. We need to make sure that our distribution of P hat is approximately normal. So we're going to check the large count condition. N times P hat has to be greater than or equal to 10. And N times 1 minus P hat has to be greater than or equal to 10. So, sample size. The sample size was 738. P hat is my proportion of success, meaning in the sample, what proportion were distracted walking. So you can either turn this into a decimal or you can leave it as a fraction, 170 over 738. If you leave it as a fraction, then you already know what the answer is, and it is 170. That is the number of successes. That is the number of people in the sample that we have that said they have distracted walk. Now we got to look at the number of failures. If 738 people total and 170 said that they do distract walk, then how many do not distract walk?
738 minus 170.
738 minus 170, which is
568.
568. And so, again, if I leave this as a fraction, I already know the number of failures, these failing people that are not distracted walking. That is greater than 10. So, because both of these work, my sampling distribution of p hat is approximately normal. It is a work of art.
The person who made this won't when they decided.
Just so you guys know, this is literally how real statisticians write up their reports when they are doing this stuff. Okay, we are halfway there, you guys. We have stated, we have planned. What's next? Do. Do. We're going to do the do. Here we go. Do. You guys all still have your writing right here. I'm just continuing right here, okay, because I don't have enough room. Do. Now, here is where you have a decision to make.
How many more things do we have?
Do and conclude. Use a 1 prop z interval. Now, I have just named the inference procedure that we're going to use. Again, this is the first of 13. I can either name it by name or you can name it by formula. If you want to use the formula, then you would have to write this formula out. Now, I'm going to tell you, most people prefer the name because it does two things. It tells you what your inference procedure is, and number two, it tells you where to go in the calculator to have it done for you. But if you prefer to remember the formula, that's fine. Just know the formulas are going to get bigger. Okay? All right, so we're going to use a 1 prop z interval. So we're going to go to our calculators. We're going to go to stat test A in our calculator. Your calculator wants to know what x is, it wants to know n, and it wants the sea level. And yes, you need to write down those things on this part right here. Literally what I wrote in purple, you need to have that on your paper, in your inference procedure. All right, what is the x? What is the value of the successes in the sample? 170. What is the sample size?
38.
And what is the confidence level? 0.95. Make sure you put it in as a decimal, otherwise you'll get an error. And then you can simply write down your interval.
They went off Budweiser. 4 seconds or whatever. Budweiser. 7 seconds. We beat them. I did my notes, Mrs. Becky. I'm just real quick like that. One day we're gonna put peanut butter on.
What did you get for your interval?
Point 1999997, comma, 0.260.
0.26073. Thank you. All right, you guys. We stated, we planned, we did, and now we gotta conclude.
Do we not put the p hat in the end?
You do not have to rewrite the p hat or the n. You do not have to. If you write them, that's fine. If you don't, you don't have to. It's not a big deal. All right, conclude. This is a sentence you should remember, or at least it should ring some sort of a bell. We are, what are we?
Very, very.
95% confident
Very, many. Awfully confident.
that the interval from 0.19997 to 0.26073. What does it do?
Captures.
Captures. Let's go. Captures
I don't remember that.
the true proportion. And at this point, basically, I'm just rewriting what I wrote in the beginning. The true proportion P of cell phone users who admit
Yeah, I call it.
to distracted walking. I know. Isn't this fun?
We have to actually write this.
This is awesome, you guys.
It'll be
We're
like a,
talking like.
Look at that beautiful piece of work that you have in front of you.
I don't feel like we should get
You could submit that to, I don't know, Distracted Driving Anonymous website, and they could put that out, and man,
They would rip this in half.
it would be amazing.
Let me tell you what, when
What
you get
in
all these
the-
bits and pieces.
Congratulations, you have just completed your first full inference procedure. Yes, this is actually what statisticians do.
I can't move scrutiny.
See, I can't ever tell in school anymore because they.
I
So we're talking per question per test. This is expected.
Oh, this would for sure be a free response question on a test.
You're telling me it's not going to be fill in the blanks.
I'll skip.
No. That's cute.
We just laughed at it.
All right. Do you guys have any questions about the four-step process?
Are we going to have to do this again anytime, like in 5 seconds?
No. Guess what? We don't have another one. In fact, we are now going to completely shift gears and do algebra. I am serious as a heart attack. Here we go. So, here's the deal, guys. Sometimes I say, you know what? I want to be 95% confident. I want my margin of error to be no bigger than, 5% or 10%, or maybe I want my margin of error to be really small, 1%. And so I know I want to be 95% confident. I know how wide I want the interval to be. And I think, I wonder what sample size would check off those boxes for me. And so this is how we can figure out what size of a sample we should take to be in a certain desired margin of error. So, our desired margin of error has to be greater than or equal to our z-star critical value times the square root of p hat 1 minus p hat over n, which, for those of you who are keeping up, what is this part of the formula from our confidence interval? This is the actual margin of error. So basically, you guys, what this formula is saying is that if I know I want to have a certain margin of error, and I know I want to be a certain percent confident, therefore I know the z-star critical value, then what size sample should I take?
Yeah.
Now, here's the only problem with this, y'all. If I have not taken the sample yet, do I know p hat? No, p hat is literally the sample proportion. I cannot use p hat if I have yet to take the sample. And I don't know how big the sample is yet because I'm trying to figure that out. So here's what you're going to do. The margin of error that you desire will always be less than or equal to the actual margin of error if you use p hat of 0.5. Why that?
I actually don't know.
Think about, why am I using 0.5?
Because like it's half.
It's the middle. It's the midpoint, right? So like, if I go one side, the margin of error would be too big. If I go the other side, the margin of error would be too small. So if I go smack dab in the middle and use 0.5, then that's going to be the exact perfect estimate, okay? So that's what we're going to go with. All right, let's do problem.
But I'm afraid that this
Tattoos.
stature more than one.
Tattoos. Suppose you want to estimate the true proportion P of students at McKinney Boyd High School have a tattoo with 95% confidence and a margin of error of no more than 0.1. Determine how many students you need to talk to.
That's a lot of
28.
for a very small.
I want to be very confident, and I am allowing a 10% window on either side. So,
105%.
That's the margin of error.
that's the desired margin of error. Very good. All right, so the desired margin of error has to be greater than or equal to the z-star critical value for 95% times the square root of p hat 1 minus p hat divided by the sample size. And we have to solve for the sample size.
I mean, this is
Now, what is the desired margin of error we want to be within? 0.1. Now, let's just see how frozen your brains got. Does anybody remember
Yes.
the z-star critical value for
0.5.
95%?
0.5.
0.654.
Wait, it's
something
I mean,
it's something it's something
0.66.
1.6. It's something 1.6.
I mean, it's two. It's two.
Remember, it's really close to 2 because of the 68, 95, 99.7. It's really close to 2. It's 1.96.
Why is it 1.1?
Huh.
Very off.
It's not exactly 2 because the 68, 95, 99.7 rule is an estimate. This is more exact.
Oh, never mind.
All right, p hat. What am I going to use for p hat? I haven't taken the sample yet. Yeah, I'm going to use 0.5.
Okay, but were you just like a guess?
Ladies and gentlemen, we now need to do algebra. This is where I find out how well you did in algebra. So, who can tell me the first step to solve for this sample size? I need to divide both sides by 1.96.
Because it's the
Now, I will explain to you at the end. You will see at the end why, but when you're doing these kind of problems, do not round until you get to the very end. So yes, that does mean you're going to have to use like 9 decimal places. I'm so sorry. All right, what is 0.1 divided by 1.96?
0.96.
A little slower.
0.0510204082.
Okay? That has to be greater than or equal to the square root of... Okay, now time out. Ladies and gentlemen, I'm about to do another step at the same time. 0.5 times 0.5. What is 0.5 times 0.5? That's going to go right here. Don't ask me where I got 0.25 from. Miss Lakey, where'd you get 0.25 from?
Where'd you get it?
0.5 times 0.5, bro.
Okay.
All right.
Thanks for that.
Ladies and gentlemen, what now? Square both sides. We're going to square both sides.
No way, I draw that in my case.
We're going to square this side. That takes away the square root. We're going to square this side.
How we got
And again, as annoying as it is, don't round. You'll see why at the end. What is the new number?
Oh my god, oh my god, I will lose my mind. No, we sure.
What's our end now?
That's what we're trying to find out. We're trying to find out what the sample size is.
Okay, so then we just.
Now, what do? We are going to multiply both sides by n. Now, some of you maybe pre-cal calculus students, maybe you already know all you got to do is switch these things. That's okay, but I'm going to go ahead and go through the process. You don't have to show that on your work, but I'm going to go ahead and show the process. We are multiplying both sides by n. So here's what we end up with. I'm going to move up here. 0.00260308 has to be greater than or equal to 0.25. All right, kids. Algebra academic weapons. What do we do now?
Ooh, multiply that fat ass. Say Cody.
We have to divide both sides by the big long decimal.
The what? The big long decimal.
The what?
The big long decimal.
Just been kind of searching for a friend. When this seems to.
So n is greater than or equal to 0.25 divided by 0.002603082. Okay, and now I am going to show you why your decimal points matter.
Okay.
What did you get for your answer? Okay, so now at this point, what you get here, we can cut it off. Here's why. Ladies and gentlemen, if my sample size has to be greater than or equal to 96.04, then what is the minimum number of people I can talk to for this sample? 97.
What decimal people?
I am talking to people. I cannot talk to 0.04 of a person, and my sample size has to be bigger than that number.
Let me tell you something about that. That is eyeball that you say.
At least 97.
Y'all were thinking.
Now, I want you guys to listen very carefully. As annoying as these decimal places are, the more you round early on, and if you keep rounding every step, you will get far away very quickly. You will get like in the 80s or up in the 120s really quickly if you round too much. Okay? And that would be an incorrect answer. All right, how we feel about this algebra? Did y'all miss algebra?
No.
Actually, yeah.
Oh, good. Well, let's do another one then. Ben wonders what college plans for all students at McKinney Boyd High School. Specifically, he wants to know the proportion of students that are planning to go to college. Ben wants to estimate to be within 5 percentage points of the true proportion at a 90% confidence level. How many students should he select? All right. Desired margin of error,
Which is 0.05, right?
has to be greater than or equal to the z-star critical value times the standard error.
Greater than or equal to?
0.05 has to be greater than or equal to. Okay, here's probably the hardest part of this problem. Does anyone remember the z-star critical value for 90%?
That's 0.16.
1.645.
This is like, you know, I'm not supposed to remember that.
You'll remember it because we're going to use it a lot.
Is there a way to like calculate?
We better.
Yes, there is a way to calculate it. Remember, if you do 90% in the middle, and you have 5% here, and you do inverse norm, and you do 0.05, 0, and 1, you'll get negative 1.645, and you drop the negative.
Wait, so we're never going to get the freaking population ever again?
Ladies and gentlemen, I would like for you to solve for n. Ready, go?
Why are we always doing 0.5?
Because we're not getting that.
All right, so once you do all of the math here, you divide by 1.645, divide by 1.645, you square both sides, you square both sides, and then you end up getting that n has to be greater than or equal to 270.6, so at least 271.
Think I can snag that bottle of beads?
I'm him. I actually did it.
Let's go!